We will continue with our discussion of buoyancy and stability. Previously, we discussed about stability of submerged bodies. Now we are going to discuss about stability of floating bodies. Let us consider a free surface of liquid and one body is floating on it. So this is a body which is floating onto the liquid surface. Floating means it is a partially immersed body. Some part of the body it is within the liquid and the remaining part it is outside of it. So the bodies whose some part it is within the liquid and the remaining part is out of it are known as partially immersed or floating type of bodies. Now here some differences we will have as compared to submerged bodies. In the submerged bodies, as the entire body was under the liquid, the centroid was at the center. Center of the displaced volume was at the center. So when we are determining the center of buoyancy, how we are determining it? Center of buoyancy is nothing but centroid of the displaced volume. So displaced volume here in this case is only this lower half. And hence, if we want to locate the center of buoyancy, we have to take centroid of this lower half only, this displaced volume only. So accordingly, we will get center of buoyancy somewhere here. But when we talk about center of gravity, if the mass is uniformly distributed throughout this body, centroid of this body, the entire body, it will give us the location of center of gravity. So centroid of the body, it will be somewhere here, and you will get center of gravity at this location. So at the center of gravity, the weight will act in the vertically downward direction, whereas at the center of buoyancy, the buoyant force will act in the vertically upward direction. Now let us consider some external disturbance is there onto this body. So some external disturbance is caused onto this body and this body has got rotated like this. So now this is the new location of the body. So after external disturbance, the body has got rotated. Now focus on this part. Initially this was the part under liquid and this is the line perpendicular to this body axis we will consider. Now after the disturbance caused, the body has got rotated, and if this body, if we keep as it is, it will also move along with the body, and now this line has taken this position. And again what we will do, we will draw one line through this free surface, and it shows that when the body has got rotated, some part of the body, which is nothing but this part, it has came out from the liquid, whereas some part of the body, which is nothing but this one, it has gone down into the liquid. And these two portions, they are somewhat similar. So whatever the part by which the fluid, the body came out, with the same part the body is going into the liquid. But now one key difference we have, and the difference is, if we consider this body axis, initially on the left and right of this body axis, we were having the same volume, because of which the centroid was somewhere here. But now when we see here, this body axis, if we consider, on the left part of it we are having less volume, whereas onto the right part of it the volume is larger, because of which the centroid will now get shifted in the rightward direction. So the centroid will not now be here like here, so it will get shifted to the rightward, so it will take some new location. Whereas when we talk about center of gravity, which is nothing but centroid of the body, it will remain as it is. So centroid will be somewhere here. So the centroid of the body, which is center of gravity, it is remaining at the same location, whereas the force will act, the weight of it itself, it will act in the vertical downward direction. But now the center of buoyancy, it has got shifted. So this shift, it is because of the change in the volume above this body axis that happened. Now on this center of buoyancy, the buoyant force will act in the vertically upward direction. This weight and buoyant force, they are having different line of actions, and because of which they will form some couple. And this buoyant force acting in the vertical direction and weight acting in the downward direction, in this position it will form a restoring couple. So it will form a couple in the anti-clockwise direction like this, and the body will come back to its original position. So this couple will be a restoring couple, and hence the body will be under stable equilibrium, we can say, because it is coming back to its original position. Now let us consider the same body we have, and now we will locate the center of buoyancy and center of gravity for it. But now the difference we have is the weight we have kept at the top of it. So at the top side we have kept some additional weight, because of which the mass now is not uniformly distributed. The center of gravity will get shifted towards top side. So now let us consider the center of gravity has got shifted here because of a very huge weight placed on the top side. So this is the center of gravity through which the weight W will act, and now the center of buoyancy will be the center of the displaced volume, which is nothing but this lower half. This is B, through which the force of buoyancy B will act. Now, if some external disturbance is caused onto this, the body will get rotated and it will take this new location. And now what will happen? After getting rotated like this, same thing will be going to happen, that previously it was having this portion under water and now under liquid, and when it is getting rotated, some part of the body it is coming out and some part is going down, and these two parts are same, one and the same, but the difference is now on the left side of this body axis less volume we have, and on the right side we have larger volume, and hence in the similar way the B will get shifted and the new locations will be like this. The G will remain as it is with respect to body axis, but the center of buoyancy will get shifted towards rightward direction. Now if we identify the weight acting through this center of gravity in the downward direction and through center of buoyancy the buoyant force acting in the upward direction, they are having different line of actions, and such a line of action it will cause a overturning couple. So the couple or moment in the clockwise direction which will overturn the body, so the body will get overturned because of this couple. So such a type of clockwise overturning couple will get formed. And now if you observe here what is happening, in both the cases B is below G. Here B is below G, as well as in this case B is below G, but in one of the case we are getting restoring couple and hence stable equilibrium, and in the second case we are getting overturning couple and hence the unstable equilibrium. So it can be concluded that the relative positions of B and G will not tell us about whether the body will be in stable or unstable equilibrium. So it will not be concluded with the use of relative positions of B and G. So there should be something else with the use of which we can determine whether the floating body it is in equilibrium or not. And to do that, what we can do is we can extend this line of action. So if force of buoyancy line of action if we extend, it will intersect the body axis here somewhere here, and this point of intersection if you consider, and if I name this point of intersection as M, which is known as meta center, which is a very important concept. So now if we see here, extending this line of action of force of buoyancy, and when it intersects with the body axis, the point of intersection it is known as meta center. In this case the meta center M it is above G. So this G and M relative positions now we have. Similarly, if we extend the line of action of buoyant force in the second case, it will also intersect the body axis somewhere here, and marking this point as M, which is meta center. In this case this meta center is below center of gravity. So it can be concluded that the body will be in stable equilibrium when M is above G, whereas the body will be in unstable equilibrium when M is below G. So relative positions of meta center and center of gravity, it will tell us about the stability or instability of the floating bodies. So the body will be in stable equilibrium when M is above G, and it will be in unstable equilibrium when M is below G. Now if we consider this G as the reference, if this G I am considering it as a reference and I am drawing one line like this, so if this distance I consider, so above this line it will be positive and below the G line it will be negative. So I can say in the other way, like if if this GM distance if it is positive, we will get stable equilibrium, and if this GM distance is negative, so this reference G we can have, and below G means it is a negative distance. If this GM distance is negative, we can say it's a unstable equilibrium. So this GM and distance between point G and M, it is known as metacentric height. So if GM is positive, the stable equilibrium we will get, and if GM is negative, we will get unstable equilibrium. So this is all about the stability of floating bodies. And one more thing is, if G and M coincides, so definitely Gm will be equal to 0. If they are coinciding, the weight and force of buoyancy will act through the same point, and will get a neutral equilibrium in that case. So it is dependent on relative positions of center of gravity and metacenter. Again, I will define metacenter. So metacenter is the point of intersection of line of action of force of buoyancy and the body axis. So it is nothing but metacenter and stability of floating bodies. Thank you very much.